Okay, so welcome members. Today we are going to see how do we handle cases when the coin is biased. So we are going to see how we get the probability of the tail and the head with a biased coin. Okay, if the coin is not biased, then it's unbiased or fair. If they don't say biased, they can say unfair. Okay, let us go through this question. A coin is biased so that a head is 3 times likely to occur as a tail. If the coin is tossed once, find the probability that the head occurs, the tail occurs. Now, know that the probability a coin has two faces, the head and then the tail. Know that for a tail to appear is 0.5 chances and also a head is 0.5 chances. Now, that happens if the coin is unbiased. But when you add all the probabilities of a coin appearing and the tail appearing, it should be 1. Meaning that the probability of a head to appear plus the probability of a tail to appear, the probability should be 1. Now, if they don't ask that, a head is 3 times likely to occur. So, if this one occurs x times, this head is 3 likely to occur. So, this one is going to be 3x. So, if this probability of this, and this is going to be 3, that's all, plus this will be equal to 1. When you add the probability of the head, not of the tail, you should get a 1. 4x now is going to be a 1, and so our x is going to be a quarter. Now from here, so that our probability of our head is going to be 3x, which will be 3 times 3 over 4. Then probability of a tail, we say it is x, which is going to be a quarter. It is. Okay, now let us go through, and that's how we handle that question. That's the probabilities of the two. Now, here, 3 unbiased. Now these coins are okay, they are not biased. Are thrown at once, find their sample space. Find the probability of that, and then we answer these questions. Now, I have 2 coins. I need 3 coins. Of course, this one is having a head and a tail, the same to this, the same to this. Okay. Now, when I throw, this one can produce a head, also this one can produce a head, and also this one can produce a head. Or when I throw, this can produce a head, also this produces a head, and then this produces a tail. Or when I throw, this can produce still a head, then this one produces a tail, and then also produces a tail. Or when I throw, this one can produce a head, then this one produces a tail, and then this one produces a head. Those are the only cases when we throw this one, when things can happen. Okay. What about when this one produces a tail? When this one can produce a tail, this one also can produce a tail, and this can produce a tail. This can produce a tail, this one produces a tail, then this one produces a head. This one can produce a tail, then this one produces a head, and this one produces a head. Or this can produce a tail, this one produces a head, and this one produces a tail. Those are the only cases we can have and eliminate. And so now it's that the sample space is 1, 2, 3, 4, 5, 6, 7, 8. So our sample space is going to be 8 with ease. Then we come to questions. So this was our part A. Then part B, Roman numeral 1. Find the probability that 3 heads appear. So probability 3 heads is going to be 3 heads. We have these are 3 heads. It's only once in 8 chances. Then Roman numeral 2. Probability 2 tails appear. Probability 2 tails appear. So 2 tails we have 2 tails. We have here tail, so these are 2, this is okay. Only 2 tails. We have these ones, Those are 2 tails. We also have these ones, 2 tails. But these ones, they never say exactly. So if they said exactly 2, we'd be looking for 2 tails only. But here also, 2 tails are appearing here. Although they are 3, but 2 tails are appearing. So this is 2 tails here and 2 tails here. So that is going to be now 1, 2, 3. So these are 3 over 8. As simple as that. The same as exact, even if they don't put exact. So 2 tails appear. Those are the cases. Then 3, at least 2 tails. We say at least 2 means probability at least 2 tails. We said at least 2, it means from 2 up to 3. To at least 2. So you have, this is 1, 2, 3. Those are the ones where you have 2 tails. At least 2, so 2 and 3. Then also have this one. So they are 4 out of 8. At least 2. Say at least 2 tails. We have 2, 2, 2, then also 3. So which is going to give you a half. Then remainder of 4, probability at most 2 tails. Now at most we say, at most 2, we shall go from 2, 1, also 0. At most meaning the highest number of tails should be 2. So we have 1, these are 2, 3. Then where we have only 1, this one, and this one. So those are 5, then 6. And then where we have 0. So here we have 0 tails. So those are 7 out of 8 chances. Then number 5, 1 tail. Probability, 1 tail, and 2 heads. 1 tail and 2 heads. Here, 1 tail and 2 heads, so that is 1. 1 tail and 2 heads, so that's 2. There, and this one, 1 tail and 2 heads, that's 3. I think they are going to be 100. 3 over 8. 1 tail and 2 heads. Then remainder number 5, no head appears. Remainder number 6. No head appears. Probability that we have no head. Where we have no head, is that it's going to be this one. It's only one case where we have no head. So it's 1 in 8. Then going to 7, calculate the percentage of having exactly 1 head. So now this way I want to calculate the percentage. First of all, you first get the probability of that. So the probability, first of all, of remainder 7 is probability. We have 1 head and 2 tails. 2 tails. It's going to be 1 head. So here we have 1 head. That's 1, 2. I think it's 2. So 1 head and 2 tails. So this is the only case. 1 head, 2 tails. 1 head, 2 tails. Then 1 head also here, and then 2 tails. That's it. It's going to be 3 over 8. Then it's percentage. So the percentage will be, you should just get this over 8, then times 100. I think this one is going to give you 7.5%. That's the percentage. So to get the percentage, just get the probability and multiply it with 100, as simple as that. So that's it, members, that we can handle that question. I wish you the best.